Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our quiz review on lessons 9.1 through 9.3 from the Big Ideas textbook for geometry. So let's go ahead and get started. The first one says find the value of x, then tell if they perform a Pythagorean triple. This is from lesson 9.1. So we would just take our a squared plus b squared and see what it equals to c squared. So that's 81 plus 144 equals x squared, which would give us 225 equals x squared. So x is equal to 15. And if you notice, 9, 12, and 15 are a triple because they would reduce to 3, 4, and 5. So we would also say, yes, it's a triple. Okay. For number 2, 7 squared and 8 squared is equal to x squared. We have 49 plus 64 is equal to x squared. That's going to give us 113. Not a perfect square, so we would just get a decimal here of about 10.6 rounded. And this one is not a triple, so we would say no. Okay. Next up on number 3, we have x squared plus 4 squared is equal to 8 squared. X squared plus 16 is going to give us 64. Subtracting 16 from both sides, we get x squared is equal to 48. Not a perfect square, so you could do one of two things. It doesn't say to simplify the radical, so if you wanted to have the option, you could do square root 3 square root 16, which is 4 square root 3, or just give me the decimal, which is rounded to about 6.9. So either one of these answers would work, and these are not triples either, so we would say no here. Okay, number 4, 5, and 6. Is it a triangle first, and then is it acute, right, or obtuse? So the first thing we want to do is add the two smaller sides to see if it's greater than the third, and it's yes, a triangle, because 24 plus 32 is 56, 56 greater than 40. So then we would just see how that plays out. So 24 squared, 32 squared is equal to 40 squared, or not equals to, but what is that compared to 40 squared? So we're going to get 576 plus 1024 is what to 1600. And if we add these together, it does give us 1600. So since 1600 equals 1600, this would be a right triangle. Okay. 7, 9, and 13. 7 plus 9 is greater than 13. So yes, it's a triangle. So we take 7 squared, 9 squared, and see how it compares to 13 squared. That would be 49 plus 81 is what to 169. 49 plus 81 is 130. That's less than 169. So since C is larger, this would be an obtuse triangle. And then our final one, 12 plus 15 is greater than 10 square root 3. You can calculate this would be about 17 point something, and 12 plus 15 is 27. So we take it 12 squared, and 15 squared is what to 10 square root 3 squared. So that's 144 plus 225 is what to 100 times 3, or 300. And 144 plus 225 is 369. And since A and B are both bigger, we're going to call number 6 acute. Okay. Next up, find the values of x and y. Write your answers in simplest form. This is your 45, 45, 90, or your 30, 60, 90 ones. So for number 7, 45, 45, 90 means I can find my hypotenuse by finding leg times square root 2. I don't know my hypotenuse, so we're going to count that as y, but my leg is 6 square root 2, and that means x is equal to 6, okay, and y is equal to 6 square root 2. For number 8, this is your 30, 60, 90, and we are dealing with two places. We can find hypotenuse by doing short leg times 2, and then we can find long leg by doing short leg times square root 3. So since I don't know the hypotenuse yet, I'm going to write that as x, but I do know short leg is 8 since that's across from my 30 according to that angles theorem. So 8 times 2 gives me 16. And then for y, that's my long leg. So y is equal to short leg, which is now 8. And then square root 3. Can't simplify that one anymore, so y is equal to 8 square root 3. Okay? Number 9, find the values of x and y. Again, this could be your 30, 60, 90. So let's start with hypotenuse is equal to short leg times 2. And then long leg could be equal to short leg times square root 3. I know my hypotenuse is 10 square root 2. And I don't know my short leg, but my short leg will be x, since that'd be across from the 30-degree mark. So let's say x times 2. I'm going to divide both sides by 2, and what I can simplify is the 10 divided by 2. That gives me 5. So I get 5 square root 2 is equal to x. And then for my y is considered my long leg. So y is equal to short leg, which now I've determined was the x of 5 square root 2. Then times by 3. The only thing I can put together are my two radicals, so y is equal to 5 square root 6. Okay? Numbers 10 through 12, geometric mean is when we multiply our two numbers and then find the square root. This is going to give us square root 72. So if you want to simplify that radical, this is going to be 6 square root 2, or decimal version 8.5. Goodness, can't draw for anything today. 15 and 20. Again, multiplying 15 times 20 is going to give us 300. The perfect square that I'm thinking of is 100 times 3, so that's 10 square root 3, which is about 17.3 in decimal form. And then 18 and 26, multiplying 18 by 26, we're going to get a larger number here, 468. And already I'm thinking 9 can go in 18, so probably 9 can go into 468. So I'm thinking square root 9 times square root 52, which then that breaks down as 52 could be square root 4, square root 13. And then this is square root 9, which is 3. So 3 times 2 times square root 13, or 6 times square root 13, which is about 21.6. Okay? Next up is our favorite. Identify the similar right triangles, then find the value of the variable. So the first thing we're going to do is write down our similar ones, starting with A, B, and C. The next one we have, since I chose to do A, B, C, that is going clockwise. The next two have to be counterclockwise, so A, D, B. And then for the final one, B, D, C. Okay, now I can use that information to look to see what I've got. I know I need to solve for x, so let's see what I've got first. It's showing me that AD, maybe I compare AD to BD. So AD is 8, and BD is x, okay? And notice I got AD and BD from here to here. So I'm going to try to use that same exploration there. Then I can say DB, which is another x, is similar to DC, which is 4. Now this looks kind of crazy because you have two x's. So when I cross multiply, I'm going to get x squared is equal to 32. But then I would just find the square root of that. So x is equal to the square root of 32. But then breaking down that further, square root 4, square root 8, or no, even better, let's do square root 2, square root of 16, which would give me 4 square root 2, or about 5.7. Okay. Again, for number 14, starting with your similar triangles first. So we'll start off with EFG. That one I just started doing in alphabetical order. So if I'm going now counterclockwise, that means everything on the inside would need to be EFG is counterclockwise, so everything on the inside of the triangle needs to be clockwise. Yep. So my next one I can do is FHG, and then EHF. Okay. Then I'm just going to pick some numbers that are matching. In this case, you maybe want to think about using the leg theorem. So in order to do that, you can find that by finding the leg is equal to your adjacent length times the entire length of the hypotenuse. Okay, so that means I'm finding the geometric mean. So that means I can take y squared, because this one's different than this one. This one was using our altitude one, but this one I'm finding geometric mean. So y squared is equal to the adjacent leg, 9, times the entire length of the hypotenuse, 9 plus 6. Okay, so y squared is equal to 9 times 15, or 135. And then I just find the square root of 135. Easier here would just be finding my decimal, 11.6, but if you simplified that radical, I'm getting 3 square root 15. Okay. And then 15, finalizing this one, identifying the similar right triangles. Now we're missing the hypotenuse length, so we'll still use the geometric mean for your legs. That's leg squared is equal to the adjacent leg times the length of the hypotenuse. Okay, so first let's label all of our similar triangles. So I have triangle JKL, and notice if I do JKL in a counterclockwise motion, then everything else will be clockwise. So KML, and then JMK. Okay, for this one, my leg is 18 squared. So 18, I'm filling that in here, is equal to my adjacent leg, which is 12, times Z, the entire length of the hypotenuse. 18 squared is 324, is equal to 12 times Z. Dividing both sides by 12, I'm going to end up with 27 is equal to Z. Okay, that'll conclude our quiz review on 9.1 through 9.3. Hopefully this helped you clear some things up. Good luck on your quiz. Remember, you can use your theorem sheet for that, and we will catch you next time. Have a great day.